Hello, everybody. If you don't know who I am Alex. I work in the Freddy Lab on the GDC project. And we're talking today about streams, commonly referred to, or observables rather, commonly referred to as streams, and we'll sort of get into that. A little bit of a preamble. Reactive programming is a thing that I think a lot of us may have heard about, or you come across it in some point. And I was really interested in reactive programming, even though I really, at the time when I first heard about it, had no idea what that meant. There's this reactive manifesto that kind of outlines all the things you need to achieve in order to have something be truly reactive. And if you do follow the reactive manifesto, you can put that nice little blue ribbon on your app or whatever. But really, sort of the gist of reactive programming is when something happens, something else happens. And that something else happened is reacts to the first thing that happens, and it's really what it's all about. Angular actually was my first time having this kind of experience. You know, you have some variable that's on the scope, and when you modify that variable, the view kind of just magically reacts for you, and that was cool. It was really convenient. I also played around with Meteor a lot. Meteor sort of touts to be a fully reactive framework, and what it did, which was interesting, is if you had somebody that makes some modification to the database, like an insert and update, then Meteor would sort of automatically notify anybody else that had a query that relied on that. And this was sort of the pub sub system. Yeah. So functional reactive programming. This is yet another term that, or FRP, may have come across, and I was really interested in this because I was getting more into the reactive stuff. And functional reactive programming, otherwise FRP, is a programming paradigm for reactive programming, asynchronous data flow programming, using the building blocks of functional programming, example, map, reduce, filter, and yeah, I know some of these things. So then I came across Bacon.js, and Bacon.js is a small functional reactive programming library. It turns your event spaghetti into clean and declarative feng shui bacon by switching from imperative to functional. This was about, for me, this was about a year and a half, 2 years ago. And I think it was really clear at this point. I'd heard the terms functional a lot and reactive a lot, so I really needed to figure out what functional programming was all about. So I read this amazing book. I highly recommend it to anyone. The Mostly Adequate Guide to Functional Programming. It's really great. And I took the stuff that I learned from this and I made tic-tac-toe using some fancy functional programming techniques. And if we enhance, we'll see that I'm using the Bacon as event stream. And here I am, finally. I've made it all the way to the end. I used streams. I use an observable here. And I did it. But of course, I really didn't know what I was doing. I used it in the most bare minimum kind of way. I could have easily just replaced it with an event listener. So yeah. ReactiveX. I'm going to spend most of my talk talking about this. ReactiveX is a library or a set of libraries, also known as Rx. ReactiveX combines the observer pattern with the iterator pattern and functional programming with collections to fill the need for an ideal way of managing sequences of events. That sounds pretty cool. It's implemented in quite a number of languages, with poor PHP down at the bottom. And it makes asynchronous programming really, really awesome. So awesome that nobody uses it. Yeah, so if we look at the Google Trends with some searches, we can say RxJS kind of bubbles. It appears maybe in 2006, but really around 2011, it's starting to get a bit of attention. And then the last little while, it's really taking off, so to speak. If we compare this against Lodash, which is a utility library in JavaScript, you can see by comparison, Lodash is much more popular. And then even more so, if we looked at ReactJS, the fancy new framework by Facebook that just came out, it really dwarfs those two things. Even though Lodash and RxJS aren't really frameworks, so to speak, you can still kind of maybe judge at least who's looking at it, and then we'll just add Angular to the mix, and you can see RxJS is basically non-existent. So what's going on? Why is RxJS this amazing tool and nobody uses it? This is a funny article. This is by Christian Alfani. He's a pretty well-known front-end developer. RxJS, the smartest, dumbest tool ever. And he goes on to say that it's a it's a great tool, but that really bad at reaching its target audience. It's not a standalone solution. You can't just drop it in and make everything magically work. It has terrible naming conventions. I find that to be pretty true. This is mostly due to supporting legacy RxJava related stuff. The documentation RxJS looks like a paper from a PhD student. They're getting better at that. RxJS 5 just got released, so I'll get into that more a bit later. Unexpected behavior, things don't work the way that it says it's going to work all the time, so that's kind of a pain. And it's hard. I think that's really what it boils down to. Like, there's all these reasons. Even functional programming, when I first started doing it, was a lot harder than its imperative counterpart. You can't just put things wherever you want. You kind of have to neatly organize things. But once you do, it works. And I think really it boils down to, like, you know what's easy? Spaghetti code. Spaghetti code is really easy to write. Not like this. What's that? Another comparison, actually, this is straight from one of the talks I saw about RxJS, is that coding with an Rx it's easy. It's like a horse and buggy. You don't need roads. You don't need a driver's license or anything like that. You just kind of get on and you move forward. And coding with Rx is like a Ferrari. It's hard, but it's awesome, right? Like, we all just want to drive in one of those. And I think that's good. That's like makes me really want to learn more about Rx. So let's dig deep. What are reactive extensions? And so reactive extensions, that's the Rx, and we're talking about observables and streams. And some of these terms kind of overlap, but really it's about these three main concepts. You have an observer, an observable, and operators. And the relationship between these three things really describes what reactive extensions is all about. To code. Let's implement some of this stuff. So, oh, this is really small. Observer, can you guys see that okay? Observable and operator. If no one complains, I assume you guys can see okay. So what is an observer? An observer could be something or somebody or some actor that basically knows how to respond to certain events in life. Like, you are in life are an observer, and you know how to respond to certain things, like something funny happens in your life and you get that value, whatever that funny thing is. Maybe it was a joke. Oops. And you do something with it. Maybe you want to go blog about it. So we'll blog on our website right here. Text. We'll add this joke value here, and we'll laugh because that's great. And maybe something else happens in your life, like you lose the internet connection, and that's sad, because nobody wants to lose internet connection. Yes, and an observable is just a function, really. There's nothing super magic about it. If we just had a function, we'll just call it foo for the time being. And it returns values, maybe I. But there's something really not useful about this, in the sense that this cannot do this. When you hit this part of the code, it just won't ever hit it, actually, because a function can only return once. So what do we do when we want to have a function that returns multiple things? And so this is where the observer comes in. We're going to take the foo function, we're going to pass in an observer, and we're going to call some of these observers methods that it knows, like something funny happened. We'll insert a joke here, and maybe it can do more than one thing, and then eventually the sad thing happens and you lose the internet connection. And actually, this is, foo's not a good name for this. Let's call this like life. This is what happens in life. And we'll have our main program down here. And when we run life and we pass you through it, then we should see that, well, let's have some new lines here. Things happen, and this is it. This is sort of the observable observer relationship. Almost, we're getting there. We have some function that knows about an observer and passes some values along through some methods that the observer understands. I'm going to modify you. So like you can't, from a computer science perspective or in programming, we certainly can't anticipate every single possible event that's going to happen. So in the observable spec, there are three main methods. I'm just going to call this, well, I'll just keep it with you for now. Maybe, you know, I'll change it. This is the observer. So the observer understands three main instructions. One is next, and next has a value. And the observer knows how to do something with it. I'm just going to take this exact thing. Oops. Value. I'll still laugh at it. Knows how to handle error events, so it takes the error. And take this along. And it also knows how to handle a complete event, which was sort of like our lose internet connection event. And it takes no arguments. It just notifies us that it's complete. And that's the observer. So the observer has a next function, has an error function, and it has a complete function. They're kind of like callbacks that the observable is going to pass along. So let's have a slightly different observable function here. We'll say funny things. I'm really bad at naming these things, sorry. It's a function, so we need to take an observer as an argument. And things like funny things or existing generally is usually something that happens over time. In the previous example, we were synchronously calling something funny over and over again, and then finally something happens, and it all just kind of happens in a single blast. But observables are really good at handling data over time, so let's use an interval here to mimic that kind of thing. And we'll call the observer's next function, and we'll also just pass a joke here because there's supposed to be funny things. And we'll have that happen every second or so. And now funny things is our main method. What did I do wrong here? Set interval. Oh yeah, I changed the name to observer. Thanks. And now this is just going to go on forever, and that's it's interesting. So now we have some relationship where we can manage things over time. Really important part of this observable spec is that we allow the consumer some way to opt out of this because this goes on forever, and maybe we want to say at some point we're no longer interested. Maybe it's not funny anymore. So what we'll do in our observable is we're going to return a function that when called will clear the interval, and that way we'll save the ID of the interval here, and we'll clear the interval, and while we're at it, we'll call the observer's complete method to indicate that something's happened. And then, so now we have some function here, we'll call this unsubscribe, that's pretty typical of that, and then maybe after, say, 2.5 seconds, 3.5 seconds, we call unsubscribe, and it's over. And so this is really the gist of it. There's not too much more to it. Observer is just somebody that knows some callbacks and has some instructions of what to do on those particular types of callbacks. And an observable is a function that takes an observer and can emit no values, lots of values, right now, synchronously, asynchronously. It really could do anything. It's a black box of function emitting. And yeah, so that's that. So now we're just down to operators. What is an operator? Operator is a special type of function that takes an observable and it returns an observable, and it might modify some values along the way, or it might do some interesting things. So let's make a simple operator function. We'll call it map. And I said it takes an observable as an argument, and it returns an observable. So in this particular case, we're going to, oh, I'm having refreeze. Oops. Returning a observable function. So another function that takes an observer. And what we're going to do here is we're going to actually call the observable method. So funny things is a function, and that we can call it, and if we know that it takes another observer, so we're going to put another observer in here. We know observers have certain types of methods. So we'll have a next method which takes a value. Oops. And it has an error method and a complete. Oops. Which takes nothing. Some commas here. And inside our, I'm missing one very important thing here. So for a map function, if people are not familiar with map is that a higher order function. It takes a function as an argument, and then you apply that against a value in a particular way. So we're going to have some sort of callback function here that's going to modify something. And inside our next handler, we're going to forward this along to the observer's next method, but we're going to pass that value through the callback first. And then everything else is the same. We're just going to forward the value. I'm going to say error here. And in the complete, we're just going to forward this along as well. And now in our funny things, we can create sort of a new observable out of this, maybe angry funny things. And we'll run this through our map function. And we'll need to do something here. So we'll make a function that takes a value, let's say value, and we'll return the value, but we'll add some exclamation marks to the end of it. So on the next line. So angry funny things runs through the map function. This is our callback function that's going to get passed into our map. And this funny things is the observable, and we'll get a new observable at the end of it. So this time we'll subscribe to our angry funny things and pass our observer in here. And if I didn't make any mistakes, then hopefully we'll have exclamation marks at the end of our value. And so these operators are really powerful because they allow you to define how values can be sort of transformed over time. This is really, it's up to you what you do in the operators when you're defining them. But it allows for some very expressive and interesting behavior. Let's make one more operator here. We'll call this one delay. But instead of a callback, we're going to take a certain amount of time. And rather than pass the value through a callback, we're going to delay the execution by a certain amount of time. Squeeze in here. We'll pass the milliseconds as an argument. And now we can put this even further. So we'll say that maybe late, angry, funny. Oh, I have some examples here from previous iterations. Late, angry, funny things is angry, funny things. Or I'm going to delay this actually by, I don't know, let's say 2.5 seconds. And now we can subscribe to late, angry, funny things. And I made a mistake somewhere. No, I didn't. It works. It works. It was late. But we have a problem here because it's supposed to be over, but it's still emitting values to us. So this is kind of not useful. When we say that something is complete, we want to make sure that it's truly complete. We don't want to get values coming in. So we just need to make one small modification to our observer. The observer needs to sort of know whether something has been unsubscribed already. So we're going to just add a little flag here. Unsubscribed, we'll initialize this to be false. And we'll add an unsubscribe method, which all it does is makes this to unsubscribe to be true. And we'll make sure that in our next handler, we don't actually emit any values unless we are not subscribed. So not unsubscribed, that is. And lastly, in our funny things in our unsubscribe function, this is the unsubscribe function here that the observable returns, we're going to call unsubscribe. And we should maybe get no values or make mistakes somewhere. Observer, observer. Thank you. Made these delays too long. Observer unsubscribe is not a function. I also made a mistake. Unsubscribe. Is that unsubscribe? Observer unsubscribe. Oh, of course. In our map function and our delay function, we need to forward that unsubscribe along as well, because we're actually calling the unsubscribe method on the observer that was passed in between our operators. So we'll have an unsubscribe method, and we're going to do exactly what we did before, which is unsubscribe, forward that along, grab that, chuck it in here, and let's make also this delay slightly shorter here so that we can see this in action. We get one message and it's over, and it's truly over. And really, this is it. We just implemented our own RxJS library here. Of course, when you're going to go into production, you might not want to use this particular library. We're missing some very important things here. We're not wrapping our callback in try-catch. We're not. What happens when one observer unsubscribes but not another one inside the chain? So there's a lot of little details that aren't ironed out in this particular thing, but this is the gist of it. And the question is now, so now we know what it is, and we kind of know how to do it roughly. And the question is sort of why? Why would you want to do this? So we saw the observer, and the observer is just a object that has some callback functions that it understands. There's an observable, which is just a function that takes an observer and returns an unsubscribe method that allows you to opt out of that subscription. And we have operators, which are functions that take observables and spit out new modified, possibly modified observables. And these are the core tenets of RxJS and of the whole observer pattern, really. And if I'm just going to say that the observable, the function that the observable uses is commonly referred to as the subscribe function. So you define a subscribe function which has the behavior of the observable over the course of any amount of time, and it returns an unsubscribe function at the end of that. So a little bit more detail. We saw this already. Next, error complete. An observable, it's a function that takes an observer. It can emit any number of values over any amount of time. It can error or it can complete, but not both. It returns an unsubscribe function that we can call, should tear down any setup logic. So if you set up in your subscription function some event handlers, timers, AJAX requests, some WebSocket connections or hardware connections like your webcam, your microphone, when you unsubscribe, this would be a good place to remove that stuff so you don't have lots of memory leaks or whatever. Other things about observables, they're lazy. Nothing happens until you actually subscribe to an observable. So you can define what happens when you subscribe, but nothing actually happens until you make that subscription. They can be canceled, they can be unsubscribed from, and they can return multiple values. If you're familiar with promises, this is quite different in that sense. When you define a promise, it executes right away, and it'll come back with just a single value. And one of the sort of good and bad things about promises is that you can't cancel them. Once you've made that promise, you're going to get it back. Operators, a function that takes an observable, returns an observable, forwards and possibly modifies values to an observer, and they're composable, as we saw in my little mini demo, that you can put a delay and a map together. And there are tons of operators. RxJS and this whole platform is really about the operators. That's where all the magic happens. So you can say that the observable is sort of the heart, and operators are the soul. It's where everything really happens. And there are a ton of them. So here are some operators. There's the creation operator. So you can take something that is not an observable by default, like a promise or an array. Even you can convert that into an observable, which would give it the unsubscription function, etc. There are transformation operators. There's so much that you can do, and this talk it's a little out of scope for this talk, but we will get into just a few of them. There's filtering ones, combination operators, multicasting operators, utility operators, conditional operators, etc., etc., etc. It's a little daunting, to be honest. This is the documentation for RxJS 5, which is kind of in beta, I guess you can say. But they're doing a pretty good job, and here's a little interactive I don't know how else to call it, but you can try to get this to tell you what operator you might want to use. You know, I have one existing, and I want to ignore values and et cetera, et cetera. Hopefully that will be good for people that are coming in like me who don't really know which operator to choose and what even they do. Barbel diagrams. Operators are described using these marble diagrams, which at first I actually didn't really know how to read, but you start here and you kind of walk along the timeline. And so the top is the first observable, and then this is the operator, and then this is the observable that comes out of it. So when you subscribe to this particular one, kind of walking along from here, you start, and then you get a value 4, which was multiplied to 40. You get 6 from 60, 60 from 6, and then A, and you get an error, and this is what that X represents. That's the error method. And if you manage to get all the way over here, then that's the complete notification. And if we look at some of these, you'll see they have these nice marble diagrams in the documentation, and they're really convenient. They're great for trying to understand what an operator is going to do, and they're littered all throughout these documentation. It's good to have a sense of how to read those when using them. Okay, let's dig into a bit of a more practical example. Or I'll just put that into new. Let's in our index file add a search box. Oh yeah, we're gonna make a cat search engine. So I have the observable library here, RxJS. So from that, I'm going to import the observable function, or it's a class. I was saying function, but the actual observable class has functions that you use to create observables. We'll see that in a sec. I'm just gonna, I'll leave that. And so let's get a copy of our input element that we just made on the screen. That's here. A little hard to see there. Just increase the size. Give our input. And input boxes have events and all sorts of events on the DOM, like clicking and moving your mouse around. And we can transform that event. Like normally, if you would have you'd say on input or on mouse over, this is the callback function that I want you to run on that. With observables, you can say, take that and return an observable, which has all those extra things that you can do with it. They have the operators and they have the unsubscription functions and whatnot. And so one of the things that we can do is we can create an input stream. And this is a convention in the observable world. We use a $sign to say at the end to say that this is a stream. And we're going to say that the observable from event, this is a creation operator, and we're going to pass in the input element, and we're going to tell it what kind of input, events we want to listen to. This input could be change or focus or blur, what have you. And then we can subscribe to that input stream. So we have a subscribe method. And this is where we pass in our observer. And we can pass in an object that has next, error, and complete methods, but we can also just pass functions directly. So the first function would be the next one. And so we'll say that we have some sort of value. And I think I have some main block that we can chuck some text into. So I'll get that. And we'll say that the inner HTML, excuse me, is what we're going to do here. Let's make a div, and we'll put that value inside there. Backtick. Am I missing a backtick? Thank you. It's all about the backticks.
Does it have to be
Main
main?
is not
Yeah.
defined. Thank you very much. I'm just going to change it. And here we have an object event. Not very useful. The value that comes out of any event is an event object, and we want to get the value out of the text box. So what we can do, because we have this observable now, is that we can actually use the built-in map function to say, take that value, which I know is the event object, and return just the target value out of it. And now we have some text. Not super useful yet, but we're getting there. What else can we throw into these operators here? For instance, maybe I don't want anything to happen until you've typed in a little bit. So we can filter out all values where meet some particular criteria. So we'll say filter any values where the length is less than 3. So now nothing happened until I actually 1, 2, 3, 4. So that could be kind of useful. But I think really the magic happens in sort of the time-based operations, which are great. So if you use Lodash or any of those types of things that come with debounce and throttle methods, basically some way to make sure that functions are only called at a certain period of time or within a certain buffer. And so there's a built-in one here called debounce. And what debounce does is it's only going to forward the value to the subscriber within a certain amount of within a certain buffer. So only like if you type like crazy, it's only going to do it once or twice, depending on how fast you're typing. So debounce. In case anyone was using RX4, they changed the API for this a little bit. It used to be just a value, would say debounce everything by 200 milliseconds, but now we need to return something called an RX scheduler, which I won't really get into at all in this talk. Observable time or interval. We'll put 200 milliseconds. And you can see that even though I'm typing, it doesn't really add anything until I've stopped typing for a little bit. So that can be convenient, especially for things like making AJAX requests, where you don't want to spam your server when you're typing. You just want to make that request when someone seems like they're finished typing. And we're going to do just that. So we're going to transform now this, rather than forwarding the value along, we're going to, in this part, use from promise to transform this value into an AJAX request. And there's a built-in AJAX fetching method here that we can say. So we have the value at this point, and we'll return fetch. And I forgot the exact URL, so I'm just going to steal it from here. It's not there. Here. This is the ultimate cat pick repository. Let's see a little bit more. There's more to the story. And so we're gonna search RA, and we're gonna send the value of whatever's in the search box along. Yeah, I definitely do. There's the backtick there. Thank you. And then that's gonna return the response object, and we want the inner JSON object. So here's the response here, and we're gonna return response JSON method, which also returns a promise, which is good because we're converting this promise into an observable using the observable.fromPromise method. Let's see what we get now. Well, nothing really. But let's see if we're making requests. Type error from event. From promise is not a function. Is it not? Is it not? No. What did I call it? From promise? That's what I'm seeing.
Did you have a Flatmap?
Yes, I certainly did, didn't I? I should just forward those values along in this particular case. I think I needed the flat map for some other reason. Okay, well, so this is a perfect time to get into Flatmap. So Flatmap is probably one of the most useful operators in RxJS, and what that does is sometimes you rather than getting a value back, so we're passing this value from the search input box, but sometimes, especially like in the case of an AJAX request, you don't get that value back. What you get, in fact, is a stream, and so now you have a stream of streams, and it's kind of like an array of arrays. And Flatmap is a utility that unboxes the thing on the inside and flattens it out for you and returns just the array with all the values inside. So if we want to say return the return all just the values on the inside of the stream, we're going to use Flatmap, get inside, flatten it all out, and then go back to our regular stream of values. So we'll just do Flatmap. And we have our value. And I think here I'm just going to return observable from promise. This looks like it's going to work. Parsing token. Return observable from promise. I don't need that. Or yes, I do. I don't need that. Okay. Let's see if we're making AJAX requests now. Promise then, it's not a function. Okay, I might have to switch into my backup code here, sorry. We're just going to steal this, everything from here. Isn't that what I did? That's what I did. All right, well, I don't want to delay this too much. I'm just going to look right over here. Let's steal all of this. That's more fun. We'll dissect this instead. So imagine, rather than having here, we're just going to continue this chain of events. So we have the debounce, we have the flat map, and then we're going to filter some things. We're going to flatten it all out, and then we're going to get the thumbnails out of, because it's the data that comes back from Reddit posts is all this like nested structures. What really we want is just the picture information from the posts. And then we're going to say, we only want things that are JPEGs and PNGs because there are some odd ones out there that are like self posts that don't actually have any images at all. And then there's another operator called distinct. Sometimes we're going to get duplicates, and sometimes like literally the exact same image. So distinct is an operator that makes sure that all the values that get passed through are unique. And the whole point of all of this is that we have one single event starter, like something that kicks everything off, and then we're going to pass it through all these transformation functions, and they're going to make sure that only things happen within a certain amount of time. We're going to transform the values. We're going to filter them based on certain ways, and this is just really convenient, one single way that we can write things all the way through. And one problem that I ran into when I was doing this is I wanted to have a way to show a loading spinner while I'm making the request. And if we're kind of like following everything we have from event input, we type, and then we map it, we filter it, we debounce it, we turn it into AJAX request, we filter it. It kind of goes directly from input values to images on the screen without giving us a chance, sort of in the middle, to say, hey, while this is happening, I want something else to happen. Like, where do I put my if statement, basically, that says, like, if it's fetching, do this. Otherwise, show the images. I'm gonna go back to my slides for a second. So this was it's a common issue in RxJS, and this is a great quote. Oh yeah, where do I put my intermediate state? What do I do with those values that just sort of they're transient? They're not part of my stream, but I need to use it to show some conditional logic inside this long chain of mapped operators. And this is a great quote from Andre Staltz, who's one of the core contributors to RxJS. The hardest part of the learning journey is thinking in reactive. It's a lot about letting go of old imperative and stateful habits in typical programming and forcing your brain to work in a different paradigm. What does he mean by that? I sure took a long time, but one of the things that he says is that everything is a stream. If you just model absolutely everything as a stream, then maybe we can make sense out of this. And one thing that's interesting about streams is that you can split them, you can combine them, and we can use that to model entire applications. So what if in our example here, rather than, I went too far. So I had this before as one long series of input events. So it goes all the way from input all the way down to URL values. Well, what if I kind of shortcut? So I have now two streams. I have one stream that is just the input values. Another stream that takes those input values and fetches images from Reddit. And then I have yet another stream right here. And this one's kind of interesting. It just takes the input values and immediately returns false. So it takes every single thing that you type into the top and just returns false right away. And how can I use that? If I merge these two streams together using merge, and merge is just yet another operator, so now I have two streams, one that just always returns false, and I have another stream that always returns images, and I merge them together and I type, well then what's going to happen? So this is sort of what I'm on top of it, so I have two, and I merge them back together, and so what's going to happen is, as I start typing, this is going to happen right away. It's going to return false. And the same stream is also going to go to Reddit and fetch some images. And then when that returns, the images will come back. So in this, now I have two states in my merge stream. I have something that's false, and now I have something that's image URL. So I can use the false, while it's false, to display a loading. And false isn't going to appear until certain conditions were met, like this this stream was greater than to length, and it was debounced. So even though it's just false, it still has the properties of the operators that came before it. Oh, so all right, let's see this in action. Let's see, did we make a cat search engine? The cats. And it loads, and we show cats. And we can get dogs too, because it's RA. Whatever you want to see, any cute things, they're all there. And I'm just taking those values, and in my subscription function, I'm saying if it is a value, if this value is truthy, then display the images. Otherwise, add the loading class to my app, and that'll show that. And that's it. That's really, it's sort of like the usefulness of using streams, that you can model how your application works as a series of events. And there's a lot that you can do with it. Very, very powerful tool. And I'll go and I'll say it again. It's not super easy. It's not spaghetti code. That stream splitting and merging is not a natural way of thinking about how to do software development, especially if you were like me and you learned on Java. Cool. Things I didn't talk about in this talk. There's more to RxJS than operators and observables and observers. There are some things called subjects, which act kind of like event emitters, if you know what that is. But basically, it's somebody that has a reference of a bunch of observers. So an observable by nature can only have one single observer that it gives notifications to. A subject is sort of this intermediary class that can forward messages to many different observers. There's schedulers, which especially in the RxJS version isn't super useful because we're on a single thread, but you can do very granular modifications of when values come in and come out. So if you need to solve race conditions or you have some thread locking issues, then you can use schedulers to really fine tune that. And then the subscription object, we did actually see that when you subscribe, you get that unsubscribe function back. In RxJS, that's actually a whole class. And you can do things like add more observers to that in order to unsubscribe from lots of different, or to have observers, many observers unsubscribe all at once. That's it. Thanks.
So if anyone has any questions, just talk into the mics as we're recording. And
oh, you know what? There's one more thing I forgot to mention. I just wanted to say I didn't really have time to talk about this in my talk, but there's this really cool framework called CycleJS, and CycleJS is everything is a stream. It uses that concept that everything is a stream, and it kind of locks you into that. And so you write your entire UI as a series of events. Like you click and then you spit out DOM nodes, and it was kind of like what I was doing in my search example, but it handles a lot of the intricacies sort of behind the scenes. It's actually a very small framework, but it's a lot of fun to write in. It's written by Andre Staltz, who was one of the core contributors, and saw some quotes by him earlier. Very cool. In a possible future talk, I could spend the entire time talking about Cycle and some of the cool things that you can do with it. Yeah, any questions?
I'll start off. So I'm wondering, so people normally these days, it seems like use frameworks like Angular, React, like you started the talk with. So how well does this play with those? And are there certain frameworks that are better with it versus other ones?
That is an excellent question. Some frameworks are better than others for it. Angular 2 actually has RxJS as a dependency. So if you're ever deciding that you're going to do the Angular 2 thing, then you're by default going to be working a lot with RxJS. And it uses this concept that you have input streams and all that stuff, and it flows into your components, your controllers, and that's how you manage your applications in Angular 2. React.js, interestingly enough, doesn't work so well with RxJS because React is completely an event-driven framework. Everything happens on these sort of React-style events where you click something and it updates something else, and then your views react. So it's harder to fit that in. People have done it. There's an RxJS, a React RxJS kind of combination. There's a lot of micro frameworks that basically take all of the cool virtual DOM stuff that React is doing and just strips away all of the state management and instead replaces that with RxJS or some type of observable library. Yoke comes to mind, but there are like a lot of these little ones that people don't really know about or use. Deku is another one. I think there are places where you can use it and it's still really convenient. Probably one of the most useful ones is, despite what framework, is if you're trying to make AJAX requests. There are some really awesome methods that come built in with the Rx AJAX libraries, like automatic retrying if something fails. You just say .retry, and if the AJAX request fails, it'll just automatically respin it for the amount of times that you specify. And you can kind of drop that in anywhere. But yeah, so I would sort of take it framework by framework to say which ones, or like to what extent you decide to use streams. Anything else? So,
Speak of the mic. How many times can you merge? Have you tried sort of merging a whole bunch together? Is that possible?
yeah, so you can. I mean, if you can sort of draw it on paper, then you can. I'd love to use my slides.
Okay.
Like, you know, if you can draw the lines in a way that it works in your diagram, then it'll work in RxJS as well. There's no limit to how much you can merge together.
I guess how do you know which one's going to run then in that case?
There's actually quite a few different merging operators.
Oh, okay.
The very, very basic one, merge, it's just always going to be the very last value that comes in. So when you type, stream comes in, and then this will represent the value false. AJAX request will come back and will represent the image URL. There's another, probably the most common merging operator is called combine latest. And it's almost identical to merge, except you have a callback function where you can be more specific about what happens in those with those values. So you say merge stream A, merge stream B, and run it through this function where you can specify how you want that to happen, and then that'll be the output. But yeah, like, there are so many different. If we were looking at the merging operators, like there was really just a ton of them. How many? So combine all, combine latest, concat, exhaust, fork join. So there's something there that's going to meet whatever need you have in terms of splitting and merging things.
So you mentioned before that you used a bit of Meteor.js. I guess this is like a more particular version of Adam's question, but does RxJS play well with Meteor's like publications and subscriptions? Or do like at that point do we even like would you ever have a case where you use both?
That's an interesting question. The pub sub stuff it works by using like MongoDB's oplog. So when somebody, it's kind of like the reactive behavior you get in Meteor kind of leaves the application framework for a little bit. Like it's going down to the Mongo layer and then coming back up and then sending notifications. In that sense, RxJS doesn't sort of, you can't sit that whole thing on top of it because there's no way, you know, like once you sort of leave, you know, you can have like a from promise kind of thing where you make some call to a database and it comes back, and then you can use that to notify other sockets or something like that. You could use it, but it's like a different Venn diagram of what reactive is in that sense. Wait, so in Meteor, you can like you make insertions and that kind of thing, and so you can have streams that feed into those. So that'd be a good place to sort of wire it in. So you take your event handlers, how you normally would. So there's like template.events kind of thing, and you turn those events into streams, which then it does whatever, and then sort of kind of like bridging the gap between, in case you need to do what RxJS does best, which is sort of time-based operations between going from your event to your Mongo layer. I'm sure there's something out there. There's somebody that's done RxJS in every possible way out there. They're not very popular, but they're there for sure. So.
That looks like we're done.
Okay, well,
Thank you.
thanks.